Okay, so part 2 of lesson 1.2. So example 3 is where we're at. We just talked about this situation up here. Example 3 just gives me the limit as x approaches 0 of the absolute value of x over x. So I know that if I just take this 0 and plug it straight in, that's not going to be okay because I have a 0 in the denominator. So I have really a couple of options. I could do a table or I could graph it, either one. So let's say I choose to do a table. So let me draw out my table again. So what's going to happen in this one is you're going to notice one side doing one thing and the other side doing another. So if I'm trying to go to 0, I'm going to put 0 right here in the middle. This is what I'm trying to find as x approaches 0. Before that, let's say I go -1 and maybe -2, -3 if I feel like I need it. I don't think I will. And then same thing here, 1, 2, and 3 this way. And I'm just going to try to get in there what I need. So you can take as many shortcuts as you want. I'm just going to start with -1 and 1 and kind of work my way out and see what it tells me. So if I put -1 in here, the absolute value of -1 is 1 over -1. So altogether, that's 1 over -1, which is -1. If I put -2 in there, that'd be the absolute value of -2 over -2. So that'd be 2 over -2, which again is -1. And that's going to end up happening with everything. These are all going to be -1 over there. So keep going that direction. It's always going to be -1. If I plug in a +1, I'm just going to get 1 over 1, which is 1, or 2 over 2, which is 1, 3 over 3, which is 1. When you divide those out, you still get 1. So I know that if I plug 0 in, I get undefined, so that's not okay. So what does that look like graphically? Let's just kind of look at both scenarios here. So what happens when you look at it graphically is everything going this direction is at -1 on the y-axis. So let's say this is my -1. Here and here and here are the 3 points that I just came up with. And going the positive direction, 1, 1 is here, 2, 1 is here, 3, 1 is here. So I'm all of this right here. At 0, it's undefined though. So I kind of have these open dots at 1 and -1, and then I have this situation here and here. So the problem is, as I'm getting closer and closer to 0 from this direction, it looks like it's just going to be 1, 1, 1 all the way. And when I'm coming from this direction, it looks like it's going to be -1, -1, -1 the whole way. So here, these don't match. When I did the table on that last example, on the last video, these very clearly both went towards 1. In this situation, they are not going to the same value. So in this situation, the limit does not exist. So a lot of times you will see this written as DNE for does not exist, and that is fine to use that abbreviation if you choose to. Okay, so then lastly, I have these last 2 examples that are actually very simple. Actually, let me go back to this for 1 second. So another situation where something doesn't exist, we talked about this yesterday, was like the oscillating situation or asymptotes. So let me see if I can find examples of those and show you real quick. So this is one situation where it's oscillating, and then a situation where it is an asymptote would be this situation. Both of those does not exist as well. Okay. So then, okay, now let's do these last 2. These are actually really easy because if I take this 3 and I do that direct substitution that we talked about earlier, I don't have to do anything else. It just plugs in really nicely. So I'm just going to do that here. So this limit equals, if I plug this 3 in right here, I get 2 times 3 minus 5. And once I plug this number in, I no longer have to write it as a limit because now I'm evaluating it. The number's plugged in. So that gives me 6 minus 5, or just 1. That's my answer. So same thing here. If I just take this and I plug it in, that gives me 3 times 2 minus 2. Well, that's 6 minus 2, which is 4. So basically what happens in these cases is the limit, so the limit as x approaches 2 is the same as, maybe I should, hold on, I should put of f of x, so of the function. The limit of the function as x approaches 2 is equal to the function at that point, which is how I ended up with just 4. I just found f of x, that was it. So same thing here, the limit as x approaches 3 of this function is equal to the function at 3, which is 1. Okay, so 3 ways that you can deal with that. Now the last one, I told you we weren't going to talk about it much. We'll talk about it tomorrow. That's this analytic approach. That is when we're going to have to use some algebra or some calculus to help us out. So maybe we have a situation that looks like this, and so I end up with something that's 0 in the denominator, but I could maybe fix that with some algebra, and then that will make things easier to just substitute in, just direct substitution. Okay, so we'll talk about that next week. Thanks.